Why is data so important? If you want to run a safe and profitable business, you have to underpin that with good quality data. So, why is it so important you get this information correct? Why is it so imperative for your business to perform well to have your data quality as high as possible? Whether you're doing a greenfield build or whether you're doing a brownfield optimization project, you need to understand the use of the data and how much it impacts people's time, costs, and general well-being about how they work. This is the stuff that makes life simpler, easier, frees up people's time, makes them much more efficient and effective for the business. If they have their hands-on good quality data. Take equipment types, for example. If you start understanding what your equipment type truly is, you can then allocate the correct maintenance to that. And again, that maintenance can be based from failure mode effects and analysis, so you understand what failures can occur and how you're going to mitigate it, which means you start getting into some real understanding of the importance of doing a job, which means you can start to prioritize your work. Because that's the thing, in reality, there isn't enough time in the day to do all the work you need to do. Therefore, you have to have a way of prioritizing. If everything is super critical, nothing's going to get done. There needs to be in a place where you understand getting the work completed in which order is key. So therefore, you need to understand your piece of equipment, what's applied to that, and what materials are required as well. And people looking around for information is a waste of time when you already had that opportunity. Whether you're talking about designing, building, commissioning, operating and maintaining, you have all these opportunities to understand what the equipment is and what you need to run it. These are things that need to be delivered on, because otherwise you end up with a very inefficient and frustrated workforce. So clients can use enterprise resource programs for running their business. They have financial modules, HR modules, they have materials and maintenance modules, and even integrity modules for managing your critical performance standards. What you want to be able to do is run your enterprise resource program to run your business. Before you then load that system or update that system, you need to know that data is good and accurate, and the quality of it is at the correct level. So what Effio allows you to do is hold that data, understand the impact across all the different aspects, then make decisions and upload it. Simple things like descriptions. Having a consistent description across the board will then make people's jobs far easier to find things and understand what's going on in the live systems, and it allows you to analyze things as well. So where do you use Effio? Effio is available with any computerized maintenance management system or materials management system. It is a staging area for that data in order for you to pull the data from your repository into a system, understand that the data is now concise, consistent, and approved. You then can feed that back out into your systems for use. This is a bit of a novel concept where normally people are trying to manage the data within the tool that they're working with. What we're advocating is you would always set these things up and approve things and understand the whole context. That's the key to what Effio delivers. It delivers a transparent and approved set of data for reloading to your system. Effio allows you to have structured, agreed, and consistent data sets across your business. And if various different forms and systems that you use in order to run your business need to interact, Effio allows you to get the foundations in place, agreed, and then allocated on a consistent basis as well. It's not just greenfield or brownfield. This is all through the life cycle that you can use this tool to deliver that quality data. Why Effio? Effio is an asset management data engine. It takes account of the whole process, everything from maintenance to integrity to materials management, and also including management of change throughout the asset lifecycle. This is a tool that allows you to hold and store your critical decisions and data points, for example, your maintenance library or your bills and materials, and then make sure that's allocated against your asset register. Why do we call it Effio? Effio is a Latin word for yield. So that's to either produce something or to be flexible. So from our point of view, we can use it on our own internal projects or with our clients, or just license it to a client to use themselves. It's very user-friendly and extremely intuitive. The functionality of Effio comes into its own because it's cloud-based. It allows people to come in from a secure two-factor authentication to allow each client to have their own domain and own ability to make changes or to read data. So this is very useful when we build data out with the client and produce it for them to then check and manage and improve. Really, this is pushing us towards how do we interact with clients? How do clients interact with each other? How departments come together? All these things can be done in a cloud-based environment, allowing decisions to be made and then allocation of that to then be produced and loaded back into whichever your CMS system or your maintenance management system. So our maintenance build approach is an end-to-end proven process that we've built up of decades of doing these things. So you identify the equipment, you work out what it is, where it is, you identify the equipment criticality, so how important is it to you and your business? Does it require performance standards against it, things like that, any legislative requirements. You then look at the equipment strategy, so how are you going to maintain this piece of equipment? What variations have you got on certain things with makes and manufacturers and model numbers that may need a slight change to it? And then once you've got your strategy agreed, or it might be actually to run it to failure, which is absolutely legitimate. Might drive your spading strategy a little bit, but legitimate strategy to run things to failure. And again, is things condition monitoring? Are they following up predictive maintenance, for instance? These things are all decided once you know what the equipment is and how important it is to your business. You then move on to, once you've got your strategy settled, how are you going to do that task? What's the detailed task instruction for the either the vendor or for the technician to carry out that task? What do they need to record? What values need to put in place? What settings are involved? These things are important to make sure are recorded inside and repeatable against those tasks that require those locations that require those tasks. Also in that area, we would put in crafts and durations, whether it's online or offline tasks, and put all those work execution parameters inside the tool for load to the CMS. Once you've got those things in place, you then move on to materials against the equipment itself. What materials are required, what bill of material, what's the breakdown, is it just a single line that's a replacement, or do they have parts to it? And if so, what are those parts and how many do you need, and things like that. And then you can attach those bombs to the planned maintenance routine you've ascribed. And then after that, once you've got all these things in place, you can be looking at optimization, where you're looking at routes for doing things like lighting circuits or testing of fire and gas detectors, for instance. You want to put them in routes by the level or by room. And then you're looking also at nesting job plans and things like that. There's also suppression to ensure you're not if you've got a sequence of events like a 3 month, 6 month, 12 month, 24 month, you're not having work orders fire more than once and doing things twice, which means you then need to go into your system and cancel them. All these things can be automatically set up. We want to think about that at the optimization stage. Also, there's packaging of equipment as well. Can we pull if a pump's going down, for instance, do we do some service on the gearbox and the motor at the same time, and any other auxiliary equipment. Also, any environmental constraints, things like that. If you've potentially got any normally unmanned installation, you may want to bundle things together. You might have harsh winters, you might have very hot summers. You may want to be in a position where you can look to concentrate your work effort in certain times of the year. We can do all that things with level loading and smoothing of your maintenance burdens. In this situation, you then want to think about how you select information to go into the CMS. This is about a choice of, does this piece of equipment deserve to be in the CMS? Does it deserve to have a location against it? What information do you want to record against it? There's fairly complex rules you can put in place, or you can make it very simple. If it physically exists on the plant, for instance, it should be in your CMS. But you may want to look at manual valves, for example, as something that's usually a debate. Do you want to keep them in? We would normally want you to think about things like, is it used for isolation purposes? If so, you will probably want to record that and ensure it works when you need it to. Otherwise, you start taking the isolation of equipment out to the system and then potentially out to the plant, which may not be what you want to do. So we've got a process flow here that asks about, does the item require individual recording of inspections, for instance? If so, it can go straight to including the CMS. It's when it doesn't require that sort of thing to say you have to have records of maintenance. You need to work out whether it's maintainable or not, and does it form part of a boundary package, things like this. And it could be potentially excluded from the CMS. Things that are excluded, we normally say, is things like soft tags, which are like software tags, for instance. They are things that exist on drawings and things, but aren't actually physically in place. There's usually a valve or an instrumentation or something, piece of equipment it's pointing to. We would keep that allocation in there. So once we've identified what we're keeping in, what we're not keeping in, we then want to think about how we extract data from, for example, a P&ID. We also look at taking data from electrical drawings and from data sheets as well. So in this place, we'd want to be in a situation where we can highlight the data that you wish to extract and the stuff that you wish not to extract. But we want to make sure it's all marked up so it's all captured. So at a later date, if you decide later on that you do want to pull some of that data in, it's still available for you. So we have a data extraction tool that can data scrape from generic information from a catalogue or anything like that. We can highlight the data we want to pull out, or we can use ones for bills of materials that use more about data sheet driven stuff, and also process and instrumentation diagrams. So in this example, I'll show you as a process P&ID, and we can see here we have different single line tags, text blocks tags, parent blocks, because this is where we want to extract the data, but we want to provide it with context. So what you've got also is the drawing numbers, P&ID titles, page numbers, revision numbers, all the sort of things that would be in the bottom right hand corner of your P&ID, which is critical information. So what we want is to have an extracted CSV file or Excel file that you can read in there that would then align with that marked up P&ID, which gives you the parent, the tag, the length of the tag number as well, which is something that is particularly useful later on, the P&ID description, the drawing number, the revision, the page number, the date it was extracted, who extracted it, and also if there's any duplicated tags. So this is something which is interesting from us, because sometimes on vendor drawings and things like that, the same tag number is used a number of times, which means it may need a little bit of contextualizing, which allows us to then put the parent tag, part of the parent tag in front of it to give it a unique identifier. So once we've identified the equipment from the drawings or the data sheets, we want to then think about how we assign the equipment type. So the equipment type we base it on is ISO 14224, which is an industry standard, which is a 4-letter coding. So a centrifugal pump would be PUCE, and so on. It means you've got good variation of different types of equipment across various different ways of grouping things. So you can group your pumps together, you can group electrical AC motors against each other, compressors, instrumentation you can group together in a coding sense. Another codes we can use, we would, if we were using like the KKS for instance, we would then be looking at mapping that internally within Effio. So from the client's perspective, they would be having their KKS code or whatever code they wish to use. We would recommend an international standard one, KKS or ISO. And that just makes it easier for lining things up and comparing things across different plants, or ensuring your maintenance strategies are linked properly to your types of equipment. That's a really important part, because as you can see here, the equipment type really drives the equipment characteristics, the type of data you want to hold within your system. So you hold slightly different information from an electric motor to a pump, for instance. Pumps are looking at flow rates and things like that. You're looking at an electric motor for voltage and potentially current and things like that. Another example would be valving. I mean, one of the main things when it comes to the practical application of changing valves out is the face-to-face value from the flanges. It's something that you can capture in your CMS and hold that, so you know when you're ordering the right type of spec of valve, the valve will fit in the place it's come out of. The Equipment type also drives criticality rules. You can use that to help to build your rules in there to make a better, more consistent allocation of criticality, and also your maintenance strategy, as I mentioned before. So once we've done this, we then want to move into the asset register and actually start building this thing and constructing it to have a parent-child relationship. So you're grouping things into systems and then equipment, and equipment breakdown into which valves, for instance, are isolating or controlling certain types of equipment. One of the things you want to think about is the equipment's main function and sub-function. So here you can see a generalized layout where you've got the asset name, the system, the main function of it, the sub-function of the equipment that's there, and then it breaks down into the equipment itself. Also, I've included some criticalities we assign to here. So what that means is, before we get into showing how that relates within Effio, you want to think about your main function is actually what is the task that that piece of equipment and its auxiliary equipment is carrying out. So you can see here we've got liquid knockout for the ERU compression is this section here. And we also have after cooling happening here. The next part of it is really important because, again, we are big believers in touching data once. So if you're looking at your drawing, let's get the max amount of information out of it in one sitting. There are other ways of extracting data. We would advocate using that, touching that information once. Pull it out, get all the information you need, and that's about giving context to data, not just getting data out. So what we here is now the sub-function. So this sub-function, first of all, is control. So you've got these valves here which are actually controlling, and that's their task. We're looking at monitoring and then shutdown and indication, and pressure relief and manual shut-off. That way we know then what that piece of equipment is truly doing. We know it's a valve, but we need to know which context it's in, because if it's a shutdown valve, there may well be legislative testing requirements for it. And then your main task equipment as well, which is these vessels, which actually show you that it's the main thing it's doing. So, how that corresponds into Effio. Within the tool, we have a secure login, first time you log in, you'll have two-factor authentication, which means you'll get an email with a code that you then have to put in. Over and above that, and then we move that, and then move on to this menu here where you start seeing all different views on the left hand side. So we have the asset register, which allows us to identify equipment, the criticality, which allows us to understand importance, the bills of materials, which gives us the material aspects of all the required parts and spares that you can associate with your asset register, your maintenance, and then reporting as well. So what we have here is the main flat view. So again, it moves from left to right across here with different various bits of information. What I'll do is I'll switch to the tree view, which gives you then the parent-child relationship, and you can open this up and expand it out and see where we've got all the different systems and levels that then breaks down into the individual parts and systems. There's also over here on this side is the basic data for this line as it's highlighted. You can now see that there's live tag number, tag identifier, all the information that's in the system here is all down on this side here. So you can see our main function that we talked about before, about what it is, and there's a drop down menu as well. So the main thing about having drop down menus is about making sure that we have consistent data. The main thing about being consistent is if there is something that needs to be changed later, and it's an error for instance, a consistent error is a very simple thing to fix. An inconsistent error is very, very difficult. You can see this by having some of the data standards in place before you start working this as well. Even the location description, we've got this, we can see here the uniformity we've got, where we've got the type of equipment, the pump, its recycle, its ethanol recovery unit. So it's a really obvious description over what this piece of equipment is and what it's doing. And that allows people to find the piece of equipment easily and simply as well. There's also sub-function as well, which again, that's a drop-down menu. You have a number of things that you can decide what to do for, and the attachment as well. So the attachment is actually the marked up P&ID that this has been extracted from. So you can actually see that that opens up with the full P&ID, and the red lines are the parent-child relationships as well. So as we start to build this, and you can see the things that everything's been marked up that needs to be extracted. We also got in here project control. So in here, these are where you can put comments in, and also you can see it's at the point of what we're trying to do is, as we step through these steps that we talked about before, those 6 steps, we want to make sure that we do it in the right order as well. We want to make sure that we have the equipment identification fully closed out before we start allocating the criticality to it. This will prevent any problems and rework later once you start assigning maintenance. This is one of the biggest lessons we've learned over the years, is you have to work methodically and accurately through in a certain order to allow you to produce this. Part of what Effio was about was to try and take the process and the steps in the order you have to go in and make sure the gap between each step is as short as possible. So as we start to use the tool, we start to be in a position where you can actually have sign-off in the tool. So as you work it, we can see here we've got the various different, where we've not started the work, we've got work in progress, we've now got it set up to do the quality assurance and quality checks that we would have in place before we pushed it to the client. So as a client, when you look in here, you can filter this purely for things that you need to look at and agree. And then once it's approved, we can then decide whether it's then loaded to the CMS. And then we move on to the next section, section 2, which is about criticality, and then on to strategy, onto task lists, and onto materials, and onto optimization. So all these things allow us to take not just the data build aspect, but the workshop requirements into an online forum. We can do this face-to-face as well. It just means you're not stepping out with the single tool with any data sheets or workbooks or anything like that. You're letting people access the data in one place, one source of truth. The same way the CMS needs to be controlled, we're doing this the same way. So when you come to load your CMS, you can see how it all interacts, and you can understand the quality of what you've got, and any outstanding or questions that are outstanding, you can make sure you can highlight in the comments box. Within the hierarchy, if you wish to move some of these things about, if there's anything that you've highlighted as out of scope tags, and we want to move some of those back into scope, all you need to do is find the parent that you want to choose, which is this one. You just drag this over, and it gives you a nice, this is again, shows the value of a good description, allows you to understand what it is. You can then take this and move it over here, pop it in there, and say that's what I want to attach. They're the 2 new ones, and you move them. Very simple, very straightforward, and it allows you to move between large, if you were, say you were redefining the boundaries of pumping stations or sections of the plant for whatever reason you'd like to do that, this would make it simple to try and change some of the parent hierarchy if required. What we then move on to is criticality. On the criticality side of things, we would want to start with always is your matrix. So normally most clients would have a basic 5x5 or 4x6, or even I've seen 8x8s. Whichever way the client wishes to do this, we can incorporate into Effio. The idea being is that this way of thinking about probability and likelihood gives you that ability to understand the risk. So again, there's a good reference part in here that we need to look at to understand, are we really under massive implication? It's very likely to happen. That means you're going to have to put something in place, mitigation-wise. What we also have in here is, once we've allocated these things, we want to then turn around and say, based on the whole of the hierarchy, what allocations have we had? And this is where we start to understand the bit we did before about grouping things into the functionalities and sub-functions. You start seeing these things here. So under high, you can see we've got pressure relief and shutdown, which you would expect to see as high criticality things. Medium, have got control and main task and some pressure relief in there. Some of the pressure relief, you go, why is that medium? You may open that up and decide, well, actually it's nitrogen, and this is the water supply. So again, these are non-hydrocarbon pieces. The pressure relief ones in here are ones that have hazardous chemicals in them. Also, when you open up the low section, there's actually, down here, pressure relief in there as well. And so as you start to refine these things, you start to understand, well, why should that be like that? And you actually understand the description of it, understand what it is, and it's actually a discharge lube oil. It's a recirc valve for lube oil for an oil pump. So you sit around and go, yeah, actually that's okay to be low. It's not a problem. And this is about understanding the context of things rather than just saying all PSVs will be high. That ends up giving you a huge amount of high things which aren't truly high. So it's about, again, trying to use your resources in the most efficient way, and this starts from the very beginning of the build. And what we can then do is we can quite clearly show how that looks like by just looking at, here's your distributions over how many high, medium and lows you have across here. So again, if you've got more, say you have a 1 to 5 rating, it's not a problem for us to incorporate that in as well. Under criticality as well, there is the exception rules. So this is sort of the main thing as this incorporation of workshops ultimately. So when you incorporate a workshop into this tool, you can then start to have your criticality rules. So here's the one we saw demonstrated. PSVs, so pressure safety valves and hazardous service, are assigned a high, and non-hazardous service are medium. And same as manual isolation valves, not safety related, they're low. So you can start to see this, and again we view it over the 4 main areas that most people will cover as well, which is safety, environment, production and business. And again, if you've got other categories like reputation, for instance, we would incorporate that. Now we've got the asset register established, we know the equipment, we know what it is, what it's doing for us. We now know the criticality of it as well, have assigned that to understand how important it is to the business. We then move on to the maintenance. Maintenance is then allocated based on the equipment type and the criticality. And then we've got any exceptions that may come out of that as well, because there are things where there are certain manufacturers where you want to have specifically certain maintenance done on that. Again, it's about base data. If you've got that identified, very easy to allocate. As a business, Add Energy has built and delivered strategies and maintenance tasks for various different clients across everything from drilling to mining to floating production, offloading storage units and land-based chemical plants. So we have a wide range in our library of basic strategies. These are things which we would always say is a good starting point. There's a lot of things that you can refine and add to, but really it's on a case-by-case basis we would do that. It's better off having something which is the basics in place that you know you're going to do before you start refining that down to the context and type of equipment it is. So in here you can see, if we open up electrical for instance, we can see we've got our maintenance library AE001, which is rechargeable battery strategy, and it goes on to different things. So again, if you as a client have your own library of maintenance strategies, we would just incorporate that in here. We would have the availability to fill some gaps that you have potentially with our library. Ultimately, it gives you a place to store your maintenance strategies. Normally these things sit in someone's bottom drawer or on the shelf somewhere, and trying to apply them becomes difficult. Same sort of thing when we talk about failure mode and effects analysis. All our strategies are based on RCM techniques, so we're looking at the mitigating task is tied back to the failure mode that we're trying to mitigate. So you can see that in here where we have the failure mode and effects analysis actually sits in here. Once you've got your failure mode and effects analysis in place, you can then load your asset register, then be in a position to be able to attribute the context of those failures to that piece of equipment to move from a failure mode and effects analysis to a failure mode and effects and criticality analysis. So in here, the basic failure modes can be in here. You can see it contains a valve to contain fluid or gas, fails to contain it, and then you can start seeing that we've got in here the control leakage and things like that. What we then move on to is the maintenance. So you've established that the maintenance library and tasks are based on FMEAs, which is great, which means you're actually then doing real tasks that add value to your business. because again, we're in the position where maintenance is there to be done because it's cheaper than not doing it. So again, maintenance has to justify itself. We would never advocate just putting all the maintenance in the world in there and saying your plant is better, safer and more productive. It's about a balance between getting the right sweet spot between over maintaining and under maintaining, and that does move around on asset life as well, because as things get older they potentially need more maintenance, and you may decide the replacement costs outweigh it, so we'll keep looking after it, or we might just replace it. So again, these are things you want to think about when we're thinking about strategies. So what we can do is look at a few different views of how we want to look at maintenance. There are two different ways we can address this by looking at the expert view, which is in here, which is the table view, which means you're breaking down the electric motors and low voltage. We can see this is now looking at the actual tags themselves and what maintenance is against them. This is be quite comfortable for people that are used to building maintenance plans for CMSs and things like that, which is great. You can see the medium and lows. That's a low voltage motor. We're not doing, we're doing a motor inspection, but we're not doing a detailed inspection because it's a low criticality. Again, this is moving around the ability to applicate maintenance based on the type of equipment and the criticality, so you can decide how that looks. Again, we understand that sometimes this sort of view can be quite hard for some people to visualize and understand. What we're looking to do then across this side is actually capture the information. So we've got the frequency, the units we're in, the type of maintenance it is, the job description. In this section here, we can actually open this piece up and actually see what is contained within that job plan text or the task. The data then is in a position where we can look to see whether it's online, whether a PM approach or a condition monitoring approach, for instance, is a condition for work offline or online, durations, the hours, the resources, the type of resource, all these things are in here. Ultimately, what we thought we also needed was a way to run workshops to get decisions on this. And again, this is about taking the experience we've had over doing this over many years and making sure that we make this accessible. So what we have is the maintenance tablet mode, which breaks it into the different disciplines or different locations, and we say here is instrumentation, for instance. This would open up and actually you've got a legend to say we in this situation they are all in progress. There's certain ones as you complete them and sign them off, you can actually see the progress. These little grey sections will move up and we will deliver, you know then as you work through the agreements and the workshops, you know what's making progress. And if there is delays in any part of getting a technical authority, for instance, from instrumentation to agree to these strategies, we can work out what that is and what help they need to free up their time, or can we help in any way to provide experts to help on these things. So if you open one of these things up, we can see the electrical part, AC electric motor opens up. In this section, you can see an EMAC02. So this is a type of a low voltage induction motor. This is when we start getting into expanding out a little bit on your equipment types and getting into subtypes. Because the maintenance, although it's an electric motor and it's an AC one, it might be low voltage or high voltage. The ISO standard does not break that down. What we want to do when it comes to maintenance, we know there are differences in high voltage motors and low voltage motors. We want to make sure we're in a position to allocate the most accurate maintenance we can. So you can actually go in here and add a new subcode to that, which again, your code, you make that in the way that you would wish to do it. Again, if there's a client and you're not using the ISO codings, we would then be able to do your own code if you would like. We would always map that back in though to ensure things are lined up properly. And then the description of it as well. So when you click into this one, as it opens up, you can see the job tasks that are applicable to this, and you can select which ones you want to apply or not apply. So if there's certain things you don't want to do any sort of detailed inspection, all you're going to do is motor inspections, then act on it. Potentially just say you're just taking the approach where you're going to just change out your electric motors, then you would just do that. You would not want to assign that. And you can see here quite clearly laid out the stuff that was a little bit more difficult to see in the expert view. You can see here quite clearly you've got a job description, you've got the type of work condition it is, the approach, the frequencies for high, medium and lows. So again, you can see why the criticality is so important to have had this established earlier, because you are going to do potentially no maintenance on a low criticality piece of equipment, and how long it takes and also how many resources. And then you can proceed to the maintenance review, which then lists all the locations that this would apply to. And in here you can start to decide whether you want to, if there's any exceptions potentially that comes out of there that you can note down, then that would be approved, and you would know who was involved in the meeting, who was there, when it was signed off, and what time and date, so you have that auditable trail of getting those decisions made. Okay, so now we move on to the bills of materials. We've established what the equipment is, how important it is to the business, also the strategy we're going to apply, and we've applied the tasks themselves. So now we have a fully allocated maintenance. What we then have to think about is, what about the materials? What about the materials we need for either spares and replacements, or from the planned maintenance we put in place, what might be required to replace certain parts and things like that. So in this section here we have a list of all the materials. So again, large amounts of things. We can look in here about the description for it as well, the manufacturer, the part number. We'll look at the material lead time, min-max levels of stock. We can hold all that information inside this. So if you already have that information residing somewhere, whether it's in the CMS or in your material management database, you can pull that information in and see it and start to make connections. So again, this is a tool for trying to understand your information and improve it and enrich it. So what we really want to look at is a bill of material. So a bill of material is the breakdown of the information. So this is a unique bill of material number for a pump. We'll open that one up, and we can see in here, I'll close that slide out, you can see in here all the parts that come with this bill of material. So I scroll down, you can see there, quite obviously this one here for this pump, this is a John Crane seal. The rest of them are all CP pumps. So what we also have here is, open this bit up, you can also go down and see the attachment, and if I open the attachment, it actually opens up and shows you then the actual manual for that pump. So you can go down and see the information that's about for the pump, which is particularly useful for kind of keeping the data all linked together. So what we do here is, we can also see in here, we've got material reference for it. We can see this is a standard way of laying out the details as well. Again, you can see it quite clearly as you run through here. You see the standardization we want to put in place. You can see the part number for it, and we've also got all the information you'd wish to put in there, how many days, all the quantities, all that sort of stuff. And we also take the pending, we also look at the QC part of this as well. So we work through this in the same way as we talked about before, which is, not started, work in progress, quality checks from our side, the client approval, and then loading to CMS or the material management database, whichever way you've got it set up. What we can also see in here is the company link. So a lot of times the people come up against problems where you can't find manufacturers, or you miss manufacturers because someone's typed it in a different way. So if I look under ABB, for instance, and search here, you can see all different aliases of manufacturers that we have in here. So we can start to pull some of these things together and understand whether it's truly a different manufacturer or is it ABB, for instance. And we hold all this information in here to try and help to pull these things together and give you sometimes a really difficult job and task and make it simpler and easier. And the last thing we can look at is reporting. So we do a lot of reporting via our Aim High tool that we use for analysing the data from existing systems, understanding PMs and various different allocations of maintenance to see how consistent or inconsistent things are across different plants. So in here we'd set up something similar to this, where you can actually see your different tag frequencies. For this is the maintenance allocation, so you can see the criticalities of tags. You can click here and you can start to move through. So this is all data taken live from Effio. So it allows you to actually understand where you've got various different bits of information in here, durations, resources, capabilities, all these sort of things for the different types of areas. So this is the bit that gives us the ability to get away from having to do reports and long conversations around about what's going on in the system and how the project's progressing to actually live dashboarding. So the client has access to these things, so we're very much in a transparent and collaborative work situation. And we've always found that provides the best results and yields the best information, because sometimes there are parts of data that are missing, and the quicker you know about the missing data and the quality of your data, the quicker we can rectify it for you. Again, good decisions are based on good data.